curves y equals x and y equals 2x squared is rotated about the x-axis. Okay, so let's see what's happening. Okay, so let's just graph each one. So y equals x is just straightforward, right? 0, 0, 1, 1, 2, 2, and so forth. So it's this way. Y equals 2x squared is a parabola, so again, they meet here. If x equals 1, we get 2. And it keeps going in that direction. So kind of looks like this. Oh boy, that's a very small area, right? So let's blow this up a little bit. So let's say this is 1 over here. So the region we're looking for is kind of like that. This right here is our region. Right there. And now we're rotating around the x-axis, so we're rotating this way. So it's identically what we have here. So it's going to be like a little cone going down, or funnel. Now the problem is, what's our integration bounds, right? So we know it's 0, which is good, but where is our endpoint, right? Where they both cross each other. And from that, we just set each one equal to itself, right? Set so y equals that to this, and we just solve for x. Let's see where we go. So bring this over, factor it out. And we can solve for x. So we know x is going to be equal to 0, which we know, and then x is equal to 1/2, just solving for there. So there's our bound of integrations. So our region we're rotating is from 0 to 1/2. So our volume is equal to integral from 0 to 1/2. And now we got to figure out inner and outer regions, right? So remember, if we rotate this way, so if I rotate this way, so therefore, my outer one is going to be this one here, and the inner one is going to be this one here. So again, if I do my circle, this portion here is y equals x, and this portion here is going to be y equals 2x squared. So outer, so it will be pi x squared minus pi times 2x squared dx. Okay. All right, so simplifying this a little bit, and I'll factor out a pi, which is much easier since they all have pi in common. So we're just going to have x squared minus 4x to the 4th dx. Again, right, notice it's a simple integration once we set it up. Right, the whole part is setting up this process. Notice the integration isn't actually that bad to begin with. Okay, so this is going to be x to the 3rd over 3 minus 4x to the 5th over 5, evaluated from 0 to 1/2 of pi, with pi there. Okay. All right, so then we just plug in the 1/2 individually and see what we get out, right, when it comes to it. So plug in 1/2, that's 1 over 8. So that's going to be 1 over 8 times 3 is 24. Yeah, 1 over 24. Minus, plug in 1/2, that is to the 5th power. Is that 16? Let me double check. Or 32, I think it's 32. Yeah, 32, so 1 over 32. And then with the 4, that gives you 1 over 8. So this is 1 over 40. And then this whole thing times pi. And there's your answer, whatever those subtractions are. If you want the exact answer, we could just, use a calculator for that, but I could give it to you real quick if you like. So approximately